Hello students and welcome to this video. In this video, we will solve question number 231 to 240 of permutations and combinations. The link to download the PDF will be in description, as well as at the end, I will show you how we can download the books from the website. So without further ado, let's get started. Question 231 says that find the number of positive integral solutions of the inequality 3x plus y plus z less than or equal to 30. So this is a typing mistake. Okay. This should be less than or equal to. So given inequality is 3x plus y plus z less than or equal to 30. Let w be a non-negative integer such that 3x plus y plus z plus w is equal to 30. Here x, y, z are greater than or equal to 1 and w is greater than or equal to 0. Because w is non-negative, so it can be equal to 0. Now, we let a is equal to x minus 1, b is equal to y minus 1, c is equal to z minus 1 as well, and d is equal to w. We get 3a plus b plus c plus d is equal to 25. So when you substitute these values in this equation, we get this, where a, b, c, d will be greater than or equal to 0. Now here, if you look carefully, a can be up to 8, because 8 is 24, but it cannot be 9, because it will make the equation unbalanced. It will become 27. Till 24, it is fine, because these three can have the value of 1. So we let a is equal to k, then b plus c plus d is equal to 25 minus 3k. Now we apply the formula, that is 25 minus 3k to be divided into 3 parts. So plus 3 minus 1, 28 minus 3k minus 1, 27 minus 3k, c 25 minus 3k, which is equivalent to 27 minus 3k, c 2. And expand this, you get 3 over 2 multiplied by 3k square matters to 3k plus 234. And here you will vary k from 0 to 8. Okay, so this I could have written as 8. And you sum this, you get 1215. Question 232 says that find the number of positive unique integral solutions of the equation a plus b plus c plus d is equal to 20. So here a, b, c, d are greater than or equal to 1. We also assume a is less than b, less than c, less than d. So we write x is equal to a, y is equal to b minus a, z is equal to c minus b, and w is equal to d minus c. So we get a is equal to x, b is equal to y plus x, c is equal to x plus y plus z, and d is equal to x plus y plus z plus w. So we get 4x plus 3y plus 2x plus w is equal to 20. And from this, we can say that sum of minimum values of 4x plus 3y plus 2x plus w will be 4 plus 3 plus 2 plus 1, which will be equal to 10. All right, so how did we arrive at this? So if you put minimum values of x, then x is a, okay? And a is greater than or equal to 1. So x would be minimum of 1. Now we look at y. Y is b minus x, okay? So it could be when x is 1, b would assume some value, right? Now b would be greater than 1 from this assumption. Okay, so b will be at least 2. So 2 minus 1 would be 1. So the minimum values of x, y, z, and w from this relationship is 1. And therefore, the minimum value of this is 10. So we get 4x plus 3y plus 2x plus w is equal to 10. That is the minimum value. Now required number is number of positive unequal integral solution of above equation, which is equal to quotient of x to the power 10 and 1 minus x to the power 4 to the power minus 1, 1 minus x cubed to the power minus 1, 1 minus x squared to the power minus 1, and 1 minus x to the power minus 1. Now after this, we just write the expansion using multinomial theorem, or rather the expansion of binomial theorem for negative indexes. And we arrive at this, we ignore the quotients of x which are greater than 10, and we arrive at the solution as 23. So we now, okay, it is not complete yet. Now A, B, C, D can be arranged in 4 factorial ways among themselves. The total number of unique solutions is 23 multiplied by 4 factorial, that is 552. Question 233 says that how many integers between 1 and 1 million have the sum of digits 18. So we are not considering 1 million here, we are considering up to 999,999. So there should be at most 6 digits. We take those digits as A1 plus A2 plus A3 plus A4 plus A5 plus A6 is equal to 18, which is given. Now A1 through A6, this should be 6, can be 0 through 9. And number is of the form A1, A2, A3, A4, A5, A6. So required number is quotient of x to the power 18 and 1 plus x squared through x to the power 9 to the power 6. Because there are 6 numbers, the power is 6, and they can assume the values from 0 to 9, so powers of x are from 0 to 9. That is equal to quotient of x to the power 18 in 1 minus x to the power 10 divided by 1 minus x to the power 6. Now we expand this, we write only 2 terms of the first expansion, 1 minus 6x to the power 10, because the next term will be 6c2 x to the power 20, and we don't need powers greater than 18. And then we write expansion of 1 minus x to the power minus 6, and we multiply, we get the required answer as 6 plus 18 minus 1c18 minus 6c6 plus 8 minus 1c8, which is equal to 25,927. Now we move on to question 234. Prove that the number of combinations of n letters together out of 3 n letters of which n are A and n are B and the rest unlike is n plus 2 multiplied by 2 to the power n minus 1. So this required number will be quotient of x to the power n multiplied by 1 plus x squared through xn to the power square. The reason of having powers 0 through n is because A and B are, the count of A and B type items are n. So we can pick 0 through n from those. So that's why the powers of x are from 0 to n. And since A and B are 2 items, so the power is square. Rest of the items are unique. So the powers of x could be 0 and 1 because the items can be chosen and they may not be chosen. And then there are n such items, so power is n. Now this is quotient of x to the power n in 1 minus x to the power n plus 1 divided by 1 minus x whole square multiplied by 1 plus x to the power n. We expand this and we get 1 minus 2x to the power n plus 1 plus x to the power 2n plus 2 multiplied by 1 minus x to the power minus 2 and 1 plus x to the power n. Now if you look at this, the quotient of x here are n plus 1, rather the powers are n plus 1 and 2n plus 2, but we need only xn, so we ignore both the second and the third term. We take only 1. So this becomes quotient of x to the power n in 1 minus x to the power minus 2 and 1 plus x to the power minus n. Now we write 1 plus x as 2 minus 1 minus x to the power whole to the power n. And then we expand the second one using binomial theorem. We get 1 minus x to the power minus 2 multiplied by 2 to the power n minus nc1, 2 to the power minus n, 1 minus x, and so on. And finally, you will have quotient of x to the power n in 2 to the power n, 1 minus x to the power minus 2, minus nc1, 2 to the power n minus 1, 1 minus x to the power minus 1. Other terms will not contain x to the power n. So then you write the quotients and you get the answer 2 to the power n minus 1 into 2n plus 2. Question 235 says that an 8-oared boat is to be manned by a crew who chosen from 11 men, of whom 3 can steer but cannot row, and the rest cannot steer. In how many ways can the crew be arranged if 2 of them can only row the both side? So number of ways in which 1 crew out of 3 can be arranged on the steering is 3p1. Since 2 particular sailors are always to remain on both sides, therefore 2 more sailors from the both side can be selected out of remaining 6 sailors in 6c2, and 4 sailors for stroke side can be selected out of remaining 4 in 4c4 ways. Now 4 scalars on the both sides can be arranged among themselves in 4 factorial ways, and 4 scalars on the stroke side can be arranged among themselves in 4 factorial ways. So required number would be 3e1 multiplied by 6e2 multiplied by 4 factorial multiplied by 4 factorial, that is 25,920. To solve this problem, you should know what is a bow side, what is a stroke side, what is steering, and all that. So unless you know the terminology, you won't be able to solve this problem. Question 236 says that find the total number of ways of selecting 5 letters from the letters of the word independence. So there are total 11 letters, E and occur thrice, D occurs twice, and rest occur once. So our first case is when 3 letters are identical and remaining 2 are identical. We can select 3 E's and 2 N's, or 3 E's and 2 D's, or 3 N's and 2 E's, or 3 N's or 2 D's. Thus there are a total of 4 ways. Case 2 is when 3 letters are identical and remaining 2 are different. Letters selected can be 3 E's and 2 out of I and DPT, or 3 N's and 2 out of IE DPT. So number of ways to select is 1 multiplied by 5C2 plus 1 multiplied by 5C2, that is 20. Third case is when 2 letters are identical, there are 2 such, and then there are 2 such letters, and the fifth letter is different. So that is 2 pairs of 2 identical letters. So it could be 2 E's, 2 N's, and 1 out of IDPT, or 2 E's, 2 D's, and 1 out of INPT, or 2 N's, 2 D's, and 1 out of IPT, that is 3 multiplied by 4C1, that is 12. The fourth case is when 2 letters are same but remaining 3 are different. Letters selected can be 2 E's and 3 out of INDPT, or 2 N's and 3 out of IEPDT, and or 2 D's and 3 out of IEPNT. So total number of selections would be 3 multiplied by 5C3, that is 30. Case 5 is when all 5 letters are different. Number of ways to make these selections is 6C5, that is 6. So adding, we get 72 as the answer. So the other method is coefficient of x to the power 5 in 1 plus x squared plus x to the power 3 to the power 2. Why the powers up to 3 are chosen is because we have 3 E's and 3 M's, and that's why it is squared. The second one is 1 plus x squared, that is up to the power of 2 for D, and it is unique, so power is 1, and then other letters are unique, so 1 plus x to the power 3. And then it's a matter of solving like previous problems to arrive at the answer. Question 237 says that find the number of combinations and the number of permutations of the letters of the word parallel taken 4 at a time. So here A occurs twice, L occurs thrice, and PRE occurs once. So for L, we have 1 plus x squared plus x cubed. For A, we have 1 plus x squared, and for PRE, we have 1 plus x to the power 3. And we need coefficient of x to the power 4. So solving this, you will get 22. The number of permutations would be coefficient of x to the power 4 in 1 plus x, 4 factorial, 1 plus x squared by factorial 2 plus x cubed by factorial 3, multiplied by 1 plus x squared by factorial 2, multiplied by 1 plus x whole cube, x whole cube, and that is 286. Question 238 says that prove that sigma n is equal to 1, sigma n is equal to 1 to n squared plus n factorial is equal to n into n plus 1 factorial. So we expand the series, we get 1 squared plus 1 factorial plus 2 squared plus 1 into 2 factorial up to n squared plus 1 into n factorial. Now if you look at 1 squared plus 1 into 1 factorial, that is 2 factorial. Now if you look at 2 squared plus 1 2 factorial, that is 3 into 3 factorial minus 2 into 2 into 2 factorial. So how we got this? So this is 4 plus 1 5, and 2 factorial, if we remain, it should take out, this will become 9 and this will become 4. So 9 minus 4 is 5. And similarly 3 squared plus 1 into 3 factorial is 4 into 4 factorial minus 2 into 3 factorial, and so on. So similarly, we can say that n square plus 1 into n factorial is equal to n plus 1 into n plus 1 factorial minus 2 into n factorial. So if you add first 2, you get 3 into 3 factorial minus 3 into 2 factorial, which is equal to 2 into 3 factorial. Adding this to third, we get 3 into 4 factorial and so on. And finally, the sum would be n into n plus 1 factorial. Question 239 says that find the value of n for which n plus 4 p4 by n plus 2 factorial minus 143 by 4 into n factorial is less than 0. So we are given this. So we expand the numerator, we get n plus 4 factorial divided by n factorial multiplied by n plus 2 factorial minus 143 by 4 into n factorial. Now we take n factorial common and we expand, we get n plus 4 multiplied by n plus 3 minus 143 by 4 less than 0. So solving this, we get 4n squared plus 28n minus 95 less than 0, which is only true for n is equal to 1 or 2. Question 240 says that find the value of n for which 195 by 4 into n factorial minus n plus 3 into n plus 2 into n plus 1 divided by n plus 1 factorial is greater than or equal to 0. So here what we do is we take n factorial common and send it to the right hand side to get multiplied with 0. So we get 195 by 4 minus n plus 1 will get cancelled here, n plus 3 into n plus 2, this should be greater than 0. And we get 171 minus 4n square minus 20n greater than 0, or 4n square plus 20n minus 171 less than 0. Roots of the corresponding equation is this. So we get n is equal to 1, 2, 3, 4 as the integral value of n to satisfy the inequality. Once n becomes greater than 4, it won't be less than 0. So with this, we come to the end of this set of questions, and let's see how we can download the books. So you can come to my website ashtavak.org and you can download Algebra, Trigonometry and Coordinate Geometry books. Coordinate Geometry book does not have coding section yet. I'm working on that, and as soon as that will be complete, I'll add that. Now, there is a piece of warning that there could be a lot of typing mistakes because I have not reviewed nor I have anyone to proofread the book. So take that with a grain of salt. Also, you don't need to wait for the video. You can go ahead and solve more problems. If you have any confusion with any question in class 12 syllabus, use the comment box and tell me your confusion, and I'll be happy to help you. Also, you can ask any question out of 12th syllabus, and I will try my best to solve the problem. So I hope that you are finding this playlist useful and informative. Thanks a lot for watching the video. I'll see you in the next video with 10 more problems. Till then, keep practicing and enjoy.